So who am I? I am a Linux engineer, plain and simple. I do work for Dell EMC. When people ask me what I do, I always have a hard time telling them exactly what I do. I like to think that I do several things: part-time technology evangelist, part-time engineer, and part-time developer, which is a good thing because I had to, for this project, this presentation, I had to use skills from those three areas. My Twitter handle, I have a whopping 49 followers. So if you want to follow me, make it 50. I appreciate that. All right, so why are we here? Why are you here? This project was created several months ago, in fact, almost a year ago. And it was really created out of a necessity for managing bare metal servers. I have a lab that I manage with about 40, 50 servers. And as a system administrator, I'm always looking for tools to make my job easier. I have several requirements that I wanted to make it simple to use, and it had to be open source. I'm a Linux guy, so it had to be open source. If you're a system administrator, and if you manage servers in development or in production, then hopefully this will be useful today. Or if you're a developer. If you're a developer and you work in IT, then I think this project can also be for you. So the agenda today, I'm going to go over several topics, just a really high-level overview of different technologies. The first one, out-of-band management, what it is, how it can help you. Redfish, which provides scalability in our solution, this solution. Ansible, which provides automation. And then at the end, I'm going to tell you how everything comes together to work and provide automated management. So what is out-of-band management? I'm assuming if you're a system administrator, you already know that, what it is, but we'll go and just give you a few bullet points. It is server management that is independent of the operating system. It's usually provided by an embedded chip on your server's motherboard. It has its own Ethernet port, and it's usually connected to a separate management network. Every time you see, when we build a reference architecture for OpenShift, for OpenStack, and you have a bunch of servers, usually it's best practice to have your management network isolated from the rest of your traffic. And so that's what that Ethernet chip's for. It goes by many names. At Dell, we call ours iDRAC, Integrated Dell Remote Access Controller. HP has its own name, ILO, Integrated Lights Out. Lenovo and IBM call theirs Integrated IMM, Integrated Management Module, or BMC, as other OEMs call it, Baseboard Management Controller. Some of the management capabilities that out-of-band give you is the ability to get inventory of all your hardware components, to detect failure, which sometimes the OS can't detect. You can configure your BIOS, and you can do firmware inventory and upgrades. So I'm going to give you just a few screenshots, an example of what out-of-band management looks like. I'll make I'll point out that this is for Dell iDRAC, but this project, this solution today really applies to any OEM. It doesn't have to be just iDRAC. I do have access to Dell servers, and so that's why I had to take the screenshots. But if you're not a Dell customer, if you manage hard servers from other OEMs, HP, Lenovo, this solution works as well. But for the sake of the demo and just giving you some screenshots, this is for the iDRAC on Dell PowerEdge servers. The best or easiest way to access out-of-band management on iDRAC is through a web console. And so this is what the login screen looks like, very, very simple, very easy to use. When you log in, you are introduced to a dashboard, and it gives you a very high-level status of all your components and of your server overall. So in this case, you see green check marks letting you know that all the hardware is working as expected, no problems there. If, for example, you want to look specific information about your server, let's say in this case hard drives, then you can navigate through the menu, you get to this part, and it's listing all the hard drives you have, the capacity, this technology, the capacity, and also most importantly, the status. You see those green check marks there on the left side of your screen. Maybe you want to get thermal information on your components, your CPUs, or your system board. Same thing, gives you the temperature on all of them. And again, the status there, the green check marks there on the left side. Let's say system event logs. In this case, there's two problems there that I wanted to point out. That the system that the controller detected, and that's the fact that one of the power supplies lost power. I think for this demo, I unplugged the power cord. That's an event that the OS wouldn't normally detect, but the out-of-band controller does. And so it detected it, it logged it, and there it is. So really, we have here a very simple out-of-band management. If you use the web access, interface. If you have one server, you have two servers, 3, 4, then it's fine. You can use the web console, but there's a problem. Number one, it's not really scalable. You're not really going to be logging into 100 servers separately, because it'll take you all day, all week. And it's not really automated, because you have to go and navigate through it with your mouse and go here and go there, and it will take you all day. So it's a great solution if you have the web management console, if you have a few servers. All right, so which takes me to introduce Redfish. So what is Redfish? And by the way, guys, have you guys heard what Redfish is? Is it like one guy, two guys? Okay, a few individuals in the room. So Redfish is an open source, open industry standard published by the Distributed Management Task Force. I had to learn that this morning, or relearn it, and it's used for hardware management. It provides a RESTful API that is used to obtain information about your server or to control them through iDRAC, in our case, through an out-of-band controller. It's built on a modern tool chain, which includes HTTPS and JSON. And it is easier to use and more secure than some of the legacy specifications such as IPMI and WSMan. If you're a system administrator, you're very familiar with IPMI and WSMan. A Redfish request is sent as an URI, Uniform Resource Identifier. So a client could be any application running on a server, or on a workstation, or even on your mobile device. What can we do with Redfish? The bottom line is you can do with Redfish almost everything that you can do on that web console that I just showed you a few slides ago. But some of the things you can do is retrieve health status, so the server health status, or your information about your hardware and firmware. You can do power management, power up, power down. You can change your BIOS settings. If you want a UEFI change, for example, between legacy BIOS mode and UEFI boot, you can do that using Redfish. You can configure your out-of-band controller itself. You can add users. You can control your network settings. You can configure hardware rates as well. And you can do firmware updates, and I'll talk about firmware updates here in a little bit, because that's something that a lot of people are very interested in, so I'll talk about that in a minute. But if you want to know everything that you can do with Redfish today, you can go to the website. It gives a very nice list of all the capabilities, and it's continually updating and improving, and so, but you can get all details on our website. And this presentation, I believe you can download it from the Red Hat Summit website, so if you missed the URL, just download the slides. So let me give you a very simple example, a few examples of what Redfish looks like. In this particular case, I'm using command line to the curl command specifically to send a URI to my out-of-band controller. All I need to do is provide the credentials of my out-of-band controller and ask for status. And so there I get a return back from my server, and it's telling me that it's okay, that it's healthy. And it's really the same information that I showed you a few slides ago on the web console, where it tells you that I'm okay, that server is healthy. Another example, for example, I'll show you on the hard drives. You send a different URI, you provide your credentials, and you get all the information on all the hard drives on the particular system. The capacity, the model, the name itself, and most importantly, the health. The exact same information that you get through the web console. Thermal information, different URI. The information that it returns, it's again your temperature and the health. Like once again, same information you got before through the web console. And finally, system event logs. You remember those that power event or data where I disconnected or unplugged the power cords. It caught it, and there it is. Same entry, same information. It's just being retrieved differently. And so you can see why with Redfish, it's easy to scale up, because you can put those commands, for example, in a bash script and send it across many servers. This is just a high-level overview of what the API, the Redfish API tree structure looks like. I'm not going to go through every single entry, just the top two. The first one is where you get basic information or inventory about your servers. And the second one, the chassis, it's where you get information about the chassis itself. For example, if you have a blade server and you want to get information not necessarily about the servers, the blades, but the chassis itself that holds them, then you can use those URLs. This is just a little deeper dive into the first tree entry, where you can dig down into it and get information, very specific information about different components in your system, the BIOS, processors, your NICs, your network controllers. Same for your chassis. You can get power, you can get temperature, thermal information. Really, this is just a few examples of everything that's available, all the APIs that are available on, at least on iDRAC. Because it provides a RESTful interface, it accepts more than just get HTTP requests, right? You can also send, you can also use post, for example. You can use patch. In this example, let's say I want to reboot my server. So I want to retrieve information and I want to run an action on it. And so here, it's very similar using curl again. I send it, specify my URI, I send the post request, I provide a header and payload, and I'm telling it there, and I highlighted it in red what the command is, and I'm sending it a command to reboot my server. Another example, let's say I want to change my boot mode to UEFI. So I use the patch request, payload, and they're highlighted in red. And so it's more than just retrieving information from your server. It's also, you can also send commands and run specific actions on your servers, which is really what's interesting, because I mean, you can get any information, it's great, but really you want to be able to manage them, and send commands to them. The Redfish specification right now, it's been improving a lot over the last 2 years, and this particular slide might be a little old, but right now the version 1. Forget what the version is right now, but it's right now specific on, or focused rather, on servers. And the intent is to expand to cover other hardware devices such as network and storage arrays. And also, as new technologies come online, the Redfish specification will improve to cover those devices, and some of them include NVDIMMs and multifunction network adapters. There's another project similar to Redfish called Swordfish, and that is what's being used to address storage devices. And the DMTF, the governing organization, over the Redfish is expanding their open source efforts around Redfish. And they're creating Python libraries, they're creating mock-up servers, all kinds of tools to interact with Redfish. If you go to the GitHub website for the DMTF, github.com/DMTF, you'll see thousands of repositories that the DMTF is creating to be able to also manage your servers. And hopefully very soon, we will add this project to, it will be a project that's also being maintained, but that will be maintained by the DMTF. Yes, sir. I knew you were going to ask me that question. It's part of the DMTF. It's a working group within the DMTF organization. I don't remember what it stands for, but it's a separate group within. It's under the umbrella of the DMTF, and it's a group focused on storage devices. So, the DMTF is made up of about 60 companies, including obviously all the major hardware vendors such as my employer, Dell, Lenovo, Cisco, IBM, Red Hat. It's not just hardware vendors; it's also software companies. And within those 60 companies, there's a subgroup that is focused on storage arrays, and they call themselves the SNIA. So, did I see another hand pop up? No. Okay. So now, going back to our picture here, we have now, instead of one smiley, because we have two, it's the same picture as before, but now you are able to scale up, because if you have you can manage more than one server at a time via Redfish. And so in this particular example, I'm just asking the status of my servers, and each server will return a status, whether it's okay or not okay. So Ansible. So this is not an Ansible deep dive. If you are interested in learning more about Ansible, there are a lot of other sessions available today and tomorrow that will go deeper into Ansible. So this is I'm just going to have like 4 or 5 slides. It's a very high-level overview, but it's just to give you an idea if you're not used to Ansible or have never used it, just to give you an idea of how it works and how it's used in this project. So in a nutshell, Ansible is automation software. It makes repetitive tasks easy. So if you're a system administrator, you're doing the same thing every day, Ansible is your friend. It's been a great tool, and I really love it. It's agentless, so meaning that when you install it, you don't have any daemons running as opposed to some other automation tools. So it means it has a very minimum footprint, and you just install the package and you're ready to go. There's no database backend, again, like other automation tools, and easy to install. Remote tasks are run in parallel, and you can specify how many threads you create when you're running tasks in parallel, and so because of that, it's very fast and very efficient. It's easy to learn, which is something that I really like. And in my opinion, it's easier to learn than shell scripts. So this is just an overview of how it works. You have one Ansible controller providing one-to-end management. Let's say you have many servers, and you can manage all of them from one central location. Just a few examples of how you can use Ansible. OpenStack, for example. OpenStack, you have so many components, so many different types of servers where you need to. If you run the installation manually, I think you still can't. You'll take hours doing it, and doing it with Ansible will be very, very fast. I don't know if the latest OpenStack package is installed via Ansible. I don't know if they switched over to it. They were using Puppet recently. Red Hat was. Another use case for Ansible, for example, if you work in IT and you can use it to secure your environment, you can use it to create firewall rules, for example, on your servers, or remove unused packages so you only have what you want, or to install security updates. So whereas before they were maybe run manually, or maybe run via a bash script. You can do that through Ansible. Another personal use case that I use Ansible for is to manage my containers in the lab. And so you're working with so many containers and images, and then you have to continually rebuild them to pick up the latest updates. It can become very labor intensive, and so you just put all of your commands in an Ansible playbook, and it makes life easier. Just a few concepts of definitions in Ansible. One of them is task. What is a task? A task is the smallest unit of work in Ansible. An example can be install a package, or remove a user, or copy this file to that directory. A play is composed of tasks, and for example, a play would be prepare a database. Well, to prepare a database, there's several different steps you have to, and so it's composed of different tasks. For example, in this case, it would be to prepare a database, you have to install it, you have to create the password, and then you have to actually create it. And then a playbook. A playbook is composed of plays. And for example, one playbook can be set up your web application, which has 2 plays, set up the database, and set up a web server. And this depicts the relationship between tasks, plays, and playbooks. Quick example, something that this is very simple. This is a little bit different than what I use in the lab. But for example, let's say you work for a cloud provider, and you have to, before you provision a VM or after you provision your VM, you have to run a series of commands to prepare it. And so before maybe you put all those commands in a shell script, you can now put them all in a playbook, Ansible playbook. The amount of text that you use in there is about the same, but the organization is much better and simple in Ansible, and very easy to add more steps or remove, and you can run it just with one command and Ansible playbook, and then provide the name of your actual playbook. And the last command, or the last concept in Ansible, the last definition is a module. Because this is what I'm telling. I will tell you in the next few slides. The core of this presentation is a module, and so whereas a playbook is the instruction where you tell it what tasks to run, a module is the code that implements those tasks. So it's really the brains of Ansible. And they can be written in any language, but the most popular is Python. And so going back to the last slide where you saw the playbook, you'll see, and I highlighted them in red, those are different Ansible modules: group, user, file, yum, and you can go and look at in Ansible and look at the code and see the actual implementation, and that's what that is. So if you're a system administrator, you will most likely just work with playbooks. But if you're a developer, then you will work with modules. Now we go back to our picture here. 3 smiley faces instead of 2. And we have, going back to it. So we have the same picture as before, except now we introduced Ansible, and we're using Redfish. We query the servers for information, or we run a command to be executed on the servers, and so everything is managed via Ansible. We get our information back from all of our servers, and they are stored in our Ansible controller. They can be stored in a database, for example. They can be stored in text files. There's different ways to do that. So let me show you now what the Ansible and Redfish look like together. Well, before I show you what it looks like, so what can you use it for? You can use it to manage your entire IT infrastructure and compute, network, and storage. Right now, the focus is on servers, but very soon you'll be able to also use it to manage your network and storage devices. And it can all be done from one controller, which can be a laptop, for example. You can automate your inventory, your monitoring, and your provisioning, OS provisioning. You can have that at scale. The best thing is that it's open source, and so you can write your own extensions if you want to, and best of all, because it is open source, again, you can contribute back to the community so that everyone benefits from your work. Upstream submission is in progress, and one of the items that I have for Red Hat Summit is to meet with the Ansible developers to make sure that we iron out all the details to submit this upstream. And Red Hat, is there any Red Hat? There you are, but in the back. Kyle? Hey, Kyle. So I'm meeting with Kyle from Red Hat afterwards to iron out the details and be able to start the process of submitting this module upstream. Once it is upstream, then the DMTF is committed to add support to the module and to support it. So that's really exciting and promising because it's not just for Dell, it's not just for my employer, but it's also really for any OEM. And so if you're not a Dell customer, then you will still be able to benefit from this work. This is a picture here that I borrowed from one of our marketing people, but the idea is that you'll be able to manage, using this module, you'll be able to manage the entire life cycle of your servers. Everything from deployment, updates, monitoring, and maintaining your servers. It is on GitHub right now. Yes, sir. The question is for OS deployments. Ask me again. There is, and the code is not there today. It's limited, but the plan is that yes, you'll be able to deploy, for example, Rail 7 and automatically. But it's not there today. But yeah, you should be able to draw out a Kickstart file and point to your install location and just run your Ansible playbook command and then go ahead and get it all done. So there's some work that needs to happen. Obviously, you have to have PXE configured. You need to have that infrastructure in place already. But once that's done, then setting up an install command, OS install command, should be pretty straightforward. Yeah. Yes, that is correct. So you can't do it. You can do it. Yes, you have to do it. It's done inbound. That is correct. So the module, the code, it's on GitHub today. That's the URL, and been lucky enough that there have been several community contributions, but the pull requests are always welcome. And so if you're a developer and you are curious or you want to add specific information or specific functionality rather, then please, all pull requests are welcome, accepted. So just a very quick example of how this works. I was going to do a demo, but I've had bad luck with demos in the past, and so I'm just going to give you some screenshots of playbook. And if you're new to Ansible, then there's a lot of information there. You may not be able to follow it, but you can follow after you download the slides. But here in this particular example, I just want to download my system inventory, right? I want to know how many, my IP address, I want to know how many sockets I have, and I want to know the health of my systems. And so very simple, just a few lines of Ansible code there. And to get that information, you execute the playbook on the command line. And in this case, I only have 3 servers for simplicity purposes. And then you get your information back. You get information back in JSON format. And there you can see I have health information. I have information about my hard drives, or not my hard drives, but my BIOS version, my boot mode, my serial number. How do you manage all the information? So for each server that you are managing, the information for each specific server is placed on a separate file in a specific directory that you specify. But it is up to each user, and that's a good question, it is up to each user to extract that information. I have it on my list of things to do to write scripts, helper scripts, to pull specific information. So like if you have 1,000 servers, for example, and you run this playbook, you're going to get 1,000 files back. And so that within itself is going to be a huge task. And so you need to have scripts to be able to pull information, specific information from those 1,000 files. And it is on my list of things to do, or hoping that someone will be able to contribute, writing scripts to extract the information that you want. How do you know how many servers you have? That's a good question. So yes, so you do have to specify, in Ansible, you have to specify specific information for all of your servers, IP address and credentials for each one. And there is a file where you specify that information of all your inventory of all the servers that you have in your environment. So, that's a one-time. That should be a one-time task. You do it up front. But yeah, unfortunately, and that's really just not just this case, but really for any Ansible. Is when servers comes and goes, yes, then that unfortunately, as far as I know, you have to manually keep that, maintain that file. So yes, so that is the only manual task in the solve with Ansible, that you do have to manually maintain your Ansible host file, is what the code is called, and you do have to specify the IP addresses of your servers. Now, one thing in this particular case, because we're not talking to the OS, we're talking to the out-of-band controller, you specify the IP address of your iDRAC, not of the OS. So, question? Mm-hmm. I am making the assumption that the passwords are the same, but if they are different from server to server, which most likely they will be, then you can specify those in your Ansible host inventory file. So, yes, sir.
In that same vein, this password has to get in place, but is there another way to do that?
You know, that's a good question. I know there probably is a way to. Because one disadvantage, the way it's implemented right now, is that your passwords have to be clear text, which obviously it's a big no-no. So I'm sure that there's a way to encrypt them, keep them in a separate location so that they're not clear text. Yes. Ansible Vault. There you go. I see you guys know more about it than I do. So, any other questions? Okay. Oh, so picking up on the last example, so if you want to know, you want to get an inventory of your environment, this will be, you can be easily imported, for example, into a spreadsheet, and you can have it handy if you want to know IP addresses or model numbers, or the last column there, the status of your servers. Let me do a time check, 11:07. Oh, time flies when you're having fun. NTP settings, another example. This in 2 steps or 2 tasks. One is to enable NTP, and the second one is to set it. And so just a few lines of YAML code. And this is how you run it. In this case, run it against 4 servers. And one thing that I wanted to highlight is that if the server doesn't implement that specific Redfish API, the module will pick it up. And in this particular case, I highlighted in red. It's letting me know that that server doesn't have that Redfish API implemented. So again, listing the same slide again, and on GitHub, and this page has instructions on how to install it. Given that it's not upstream yet, how to download, how to install it. You clone the repository, but it also has very specific examples if you're interested in playing with it, and helper scripts that will help you be able to use it. Some resources to learn more about it are here. I'm not going to go through them, but they're there for your reference. And to conclude, it goes without saying that automation and scalability are useful when you're managing hardware. The module has been tested mostly on Dell EMC platforms, but it should work on any out-of-band controller that implements the Redfish API standard, and I know some of the other OEM vendors do support it. So it was really designed to be as simple as possible to use and to extend. So that's a requirement that I had for myself when I started working on this, that it had to be very easy for others to use and to extend, because I didn't want to do all the work myself. And that's pretty much it. So thank you for listening. I'm hoping this was useful, because all this work that I've done and that I spent on it, and this presentation that I'm doing right now, it's really for nothing if it's not used. And I know we have some customers that have used it and are happy with it. Some have asked for extensions or add functionality, and that's great to hear. But I do take every opportunity that I have, like Red Hat Summit, to talk about it, and more importantly, ask everyone to use it and provide feedback. Tell me if it's good, tell me if it sucks, and what I can do to improve it.